In this section, we talk about the deformation gradient, because deformation gradient is the general term to describe deformations. Okay, we have come to a stage now. What stage? The stage that we find out the classical theory of strain is not that correct. Okay, not very correct for general deformations. So what will be the correct answer for us? In order to find out this, we had to go back to the very origin. Okay, go back to the very origin situation, and then to derive our concept step by step. Okay, and then see what kind of physical quantity will come out. OK， 我用中文补充一下，就是我们知道之前学的大学部学的那个应变不太对，然后呢想要发展一个正确的理论，所以要发展正确的理论呢，就要从最原始的想法来一步一步很仔细的来推出来。希望能够找到一个正确的做法，这样。所以呢，从这一节开始呢，我们把最原始的想法呢，来提出来，然后呢，一步一步来导出我们的答案。OK， what will be the most original concept here? Let me show you. I always like to use the simple beam because those students in civil engineering are quite good at this model. So I like to use this model to illustrate our idea. Okay, the beam will deform. Will be deformed by some loading. Okay, and then inside every point, for example, point A, point B, point C. No, not necessary here. Point C. See, there are a lot of material points. In fact, infinitely many inside a beam. Okay. So these points will also deform. Okay, we did talk about such kind of picture before. Okay, now we have a duty to derive the correct term for the shear strain or strain. We use this model again. 我们曾经用过这种的表示法，现在再用一次，因为我们有任务去做一些事情。Okay, so for every material point, we give it a position vector. Okay, this is the undeformed coordinate. This is the deformed coordinate. Okay, we talked about this before, so I just use the rotation before without explaining it again. So we have the relation between y and x. You may ask me how we can get this function. Okay, I just tell you, be patient. After you had learned all this theory, and then we will understand that we need to solve some boundary well problems, and then we will get this. Okay， 就是我们这个怎么来的呢？这个就是你学完以后呢，我们再用一些数学的手法把这个给算出来。但在这边在现在的话，就把它当成已知的已知的一个函数。At this stage, we take it for granted that we have such kind of relation. Okay, and then we can see this point we have one y, one x, and this point we have another x, another y, right? We have a lot of y and a lot of x. Okay, and then try to differentiate this relation by assuming that the time is fixed, okay? And then we get this relation for fixed time. So we get the relation between the material points, material line, okay? This is the material point. Material. This is deformed position, this undeformed position. 这个就是那个材料点的那个变形前跟变形之后的位置向量。Okay, here this position vector are for the material point. Okay, PT means that point. Okay, material point. Okay, point by point, 一点点来算。Here, this is the material line. Okay, and this is two. Before and after the deformation, 这个就是在变形前跟变形后的材料线。And we have the rotation like this, very important rotation. We denote this one by F, called the deformation gradient. F okay, deformation gradient. And this deformation gradient is a very important object to connect to connect different material lines. See, if you have we have dy equal f dx. Okay, if you have a material line deformed, understand? You have a material line, and then after the deformation, you go to dy. Okay, for example, you have a material line here. after the deformation, the material will be like that, and they are connected by the matrix F. OK， 就是所以这个矩阵 F 看起来是很重要的哈，非常重要，因为呢，它告诉你这个材料线在变形前跟变形之后的资讯，对不对？所以这边我讲过，我们讲了是一个回去最远点来考虑什么是变形 ，OK？ 我们现在就是要做这个事情哦，一个广义的材料线跟广义的材料线它怎么变 ？OK？ So see here, we are going back to the very beginning, to consider the most original information about the materials. Okay, so here the deformation gradient matrix is very important. Okay, let me draw a picture here. We draw this picture before, and then we can draw it again in order to clear our picture. Okay, it looks more beautiful. Otherwise, the blackboard is too dirty. Okay, let me give you a more beautiful picture for this. Yes. Y vector, X vector after the deformation. And here we have one material in this direction, and other material in this direction, and one more material in this direction, and one more material in this direction, one more here, a lot. See, around a point, we have infinitely many materials, and how they deform, where they go to here. This 1, 2, 3, 4, okay? This material and this material, where they go? Now, in this example, the material in the horizontal direction is no longer horizontal now. It becomes a little bit inclined, okay? Tilt up, okay? 就是我们这边的材料线有很多条，这条材料线水平的材料线 ，horizontal 的材料线就变形之后已经弹上去了，对不对？不一样。然后第二条呢 ，the second material may be deformed here, deformed in this way. In general, this material is the position and direction of this material is different from this material. Okay, and the third one will maybe located here. Okay, and then maybe find the fifth material may be deformed in this way. Maybe the fourth. Okay, understand? So, before the deformation, we have the distribution of some material around one point, point B. Okay, point B. And after the deformation, this material will send to different directions. Okay? By what? By this relation. Understand? Okay. All these deformations can be represented by this relation. dy equal to f times dx. And also, this relation will hold at every point. Point C, we have the similar thing. Point A, we have similar thing, all by this relation. So, of course, this relation is very important. Okay. Okay, the material line around this material point will be sent to the material line here. Okay, like this. And also the material line, this dx and this dy, they will be connected by, right? See here, f is a function of x, means that at different material point, this matrix will not be the same. For example, at the point x1 equal to 3, x2 equal to 1, x3 equal to 6. And then you have a special matrix of deformation gradient. If at other point x1 equal to 5, x2 equal to 3, x1 equal to 1, for this material point you have different different expression of the deformation gradient. 就是这个叫做那个变形梯度deformation gradient 呢，它每一点都不一样你不要以为是一样，它是材料点的函数。如果你不同的材料点的话，有不同的 deformation， 那当然嘛，因为不同的材料点变形不一样，我们才有细唱对不对？否则每一点的材料点变形都一样，那就太简单了，那个力学问题，对不对？ See, of course, at different material point we will have different deformation gradient. Otherwise, the mechanical problem will be too easy, right? Too simple. So at different point we have different different deformation gradient. So here, this material line will be sent to this material line by this relation, and also at point C, we have material lines like this. And this material line will be sent to here. This one, this one, this one, this one, and this one may be like this. This one, this one, this one may be like this, and this one may be like this. Okay, so the material line around this material point will be sent to here. This dy, a lot of dy, the dx, this dx, this dx, a lot of dx. Okay, and this dy and dx will be connected by Understand? We have a lot of material point, and around every material point we have different material lines, and all these material lines are connected by this simple relation. So now you can understand that the relation dy equal to f dx is very important for us. Okay, let me show you some example here. Simple shear. (2D) case, okay? y1 equal to x1 plus x2, y2 equal to x2. Okay, this is the one of the most simple example to illustrate the idea. Okay, what will be the deformation look like? Okay, at x2 equals 0. For x2 equals 0, what I mean? We talk about here. We have a okay. If we talk about the line here, x2 equals 0, right? x2 equals 0 is this line BC. Every point on this line have the property that x2 equals 0. Then what we have? We have y1 equal to x1. So fixed, because it doesn't change. y1 equal to x1, this is the deformed position, this is the undeformed position. It doesn't change. y2 equal to x2 is fixed too. Okay. So along this line, all the material points are fixed. But how about this? x2, for example, equal to what? To 5. Along this line, what will be the deformation? x2 equal to 5 now. y1 equal to x1 plus 5, and y2 equal to x2. This one still fixed, but this one move to the right. Okay, move to the right. OK， 这往右移了，往右移，这个y1这个方向往右移，但 y2不变了，表示它没有往上移，y2 equal to x2 is fixed. It means that the material line won't go up, or will not go down, will not go up. It just keep the same keep the same vertical level. Okay, so because y2 equal to x2, this material line only deform in this way. It won't go up, it won't go down. 不会跑上去，也不会跑下来。因为 y2 等于 x2， 所以这条线呢不会跑上去，也不会跑上来。但是这边呢 x1 呢，每一个 x1 都要加5哎，对不对？所以它就要往右移了。OK，because every material point past 5 the position coordinate past 5, so the material line will move to the right side. Okay, will be deformed like this. Okay, this material line AD will be deformed into this material line, and BC won't change because it is fixed. Okay, so here it is fixed. This material line is fixed. So as a result, okay, we are having a simple shear. Okay, this is a deformation of simple shear, and we want to look at the material line movement of several points by this simple shear motion. OK， 我们呢就利用这个例子来看看，在这个不同的材料点上面，它的材料线是怎么给变形的啊？好，那个麻烦你擦擦黑板。明房，谢谢你。Okay, let us look at the calculations of this example. Okay. We first differentiate this relation with respect to x1. Get 1. Okay, this is the mathematical expression for those components of the deformation gradient. So okay, like this. F11 just this term is just here. F12 is just F21 is just F22 is just like this. In fact, okay, we can use this expression to represent this relation. Okay, and go ahead, we put all this value inside. Okay, this is the deformation gradient of this simple shear motion. Okay, especially it is a homogeneous deformation, means that it doesn't change point by point. OK， 在这个问题上面啊，这个变形梯度啦是 homogeneous 是均匀的意思啦，就每一点都一样哦，所以就容易理解了啊。以前前几堂课讲的那个 deformation gradient 呢，就 point by point 的，对不对？每一点都不一样的。OK， the deformation gradient we talk about several classes before were more complicated. Means that by that time the deformation gradient was a function of position coordinates. So they will be different point by point. Here, the example is easy because it is just a constant. Okay, it doesn't change when the material point changed. Okay, 就是那个不同的材料点呢，都是同一个变形梯度，那没什么问题了啊。所以呢，我们先有一个这样的关系。We have this relation like this. This is the y vector, and f is 1, 1, 0, 1, dx1, dx2. Okay, and then we have this relation. This is the relation for the material lines. Okay, let us look at the picture here. For example, we look at a square, plate with the boundary of 5 by 5, and then we look at, for example, we look at the point 3, 2. Actually, every point will have the same deformation gradient as we mentioned before. Okay, 3, 2 is a material point we want to discuss. Okay, 我们就讨论这个材料点哈。3, 2 A. Point A is 3, 2 so we just mark down material point. A. Okay, and then we erase the backbord and introduce a new axis here. For the what? For the but it is not that big, okay? Because this dx1 is an infinitesimal quantity, okay? But we introduce a local coordinate. For the shape of what? Of correct expression. We don't want to write the x1, the x2 because the x1 and the x2 should be very small. We just use two bases, E2 and E1. Okay, and then you understand what they are. We introduce a local coordinate， 就是局部的一个坐标哈，跟这个不一样。Okay, and then we can talk about the material line here. This material line, dx pi, okay, equal to 1, 0, delta. Okay, delta is a small quantity. Delta tend to 0. Okay, and here and here, dx double pi, another material line is 1 over square 2 delta. And this one, dx3 is equal to 0.1 delta. So as a result, we have okay, and then we want to calculate delta tend to 0, and then F equal to 1101. Maybe yes, 1101. Okay, and then we have the relation to find out okay, and then this material line, where will it go? It go like 1 equal like 0, 1 delta. Okay, so okay, you deform in this way. And also, by the same reason, we can calculate another material line. Okay, and then we have 2 over square 2, 1 over square 2 delta. So this material line will go to here. And then we can draw our picture. Okay, we have two materials, how they deform, but you understand that the square plate have been deformed by a shear motion. So this point will become here, okay, this point A, and in the new configuration， 在一个新的变形里面呢，它就在 A pi 呢 ，A pi 呢，然後這條線 ，this point will be deformed into here. So as our understanding is still in the horizontal direction, according to this result, because 1,0 here. Okay, this is the 45-degree material line now become not 45 degree anymore, become about 60 degree. Larger than 45. Understand? So this material line had rotate and also prolong a little bit. Okay, so in this way, we can calculate the deformed position of every material line. I just give you some example here. So there's a homework. Okay, at the point x1, x2 equal to 4, 1, what will 4, 1 here? Yes, of 1, 4. What will be the deformed material line? Okay. Deformed material line here, 1, 4, and we have calculate this deformed material line by yourself. Okay, just like that. Okay, these three material lines will be deformed into different material lines. I want you to calculate the deformed material line of the x1 pi, the x pi, and the deformed material line of the x2 pi, and the x double pi, and the deformed material line of the dx triple pi. This is the homework of this subsection. Please finish it and turn it to me at the right time.